Welcome back, everyone. In this video, we're going to use Google Colab to implement gradient descent and backpropagation from scratch for our network. Okay? And remember, this is our network. We have an input of x equals 2, we have a true label of y equals 20, and we have the initial weights w1 equals 2 and w2 equals 0.5. And for gradient descent, we're going to use a learning rate of 0.01. Okay, so I just opened a new Colab notebook. I'm going to rename this as backprop notebook, and I'm going to connect to it. Now, I'm sure you've heard of Google Colab. If not, it's essentially a online Jupyter notebook provided by Google Cloud, and it allows you to use a GPU or CPU. And right now for us, a CPU is perfect because we're not going to be doing any big implementation, of a massive neural network with hundreds of thousands of weights or millions of weights. So a CPU is going to be enough for our simple neural network. Okay, and we're going to do this from scratch. So we're not going to be using PyTorch or TensorFlow. Okay, all we're going to import is NumPy, and I'm going to import NumPy as NP. Okay, now we have imported NumPy, and let us start over here by implementing the forward pass. Okay, so this is going to be the forward pass. So I'm going to denote it like so. And it's going to be a function, def forward underscore pass. And it's going to take 3 inputs. It's going to take x, our input, w1, our first weight, and w2, our second weight. And given an input x and weights w1 and w2, it's going to calculate the hidden node, which is h, and the final output y hat, which is equal to h times w2. And it's going to return h and y hat. So if we come back over here, it's going to return h, okay, like this. This is h, and it's going to return y hat. Okay, so let's implement this. We're going to say that h is going to be equal to x multiplied by w1, and then we have y underscore hat is going to be equal to h times w2. And actually, let's have a space here as well, so it's more readable. So over here, we have h equals x times 1 and y hat, which is h times w2. So we're setting up our forward pass. Okay, and we're simply going to return h and y hat. Okay, now we are done with the forward pass. It's a simple neural network, so not too much, right? Then the second thing that we're going to implement is going to be the loss function. Okay, so I'm going to come over here and say this is the loss function. And over here, we're going to say define the MSE loss, which is, remember, the mean squared error. And the MSE loss is going to take y, which is the true value. It's going to be 20, and y hat, our prediction. And remember, we're implementing the mean squared error with a single data point. So this is only going to return 0.5 times, and then we're going to have y minus y hat squared. In Python, if you do the double asterisk, that's going to raise it to the second power. Okay, so essentially what we're doing is we just implemented the mean squared error for a single item. So it's 1/2 y minus y hat squared. Okay, so that's what we've done over here. Now, in the next video, we're going to define basically the backbone of our network, which is going to be, the backbone of our code, which is going to be calculating the gradients and backpropagation. It's not going to be difficult, but just be prepared that that's what we're going to be doing in the next video.